Class B networks. As we know, the IP address is 32 bits long, divided into 4 sections. That's why we call it as dotted decimal. The first byte followed by second byte, third byte and fourth byte, each separated by a dotted decimal. Now, the characteristics of Class B network is that the first 2 bytes represent the network part and the third and the fourth byte represent the host part. So if I have to take the third byte and the fourth byte, combine them together, 2 bytes equal to 16 bits, and with 16 bits I get the combination of 2 to the power 16 is equal to 65536 numbers. Now, to get the total number of valid hosts, I have to subtract 2 from it, and that gives me 65534. Now, why did I subtract 2 from it? Because we need to discount the network address and the broadcast address. So that's the reason we have taken out 2 from it. So for any given Class B network, the total number of hosts that are available in each network are 65534. Okay, important number to keep in mind. 65534 is the number of valid host IP addresses that can exist in any of the Class B networks. Okay, and another thing, simple rule that one needs to remember is, if we are given a Class B network, how do we find out the network address or the broadcast address? Simple. Just for the network address, set all the host bits to 0. Leave the first 2 octets that designate or denote or tell this is the network part. Leave them as it is. Leave the network part as it is, and convert the host bits to 0. That's where will give you your network address. And similarly, if you have to given an IP address, if you want to find the broadcast address for it, just leave the network portion, that is the first 2 bytes as it is, and convert the last 2 bytes into all ones, that is the 16 bits set to all ones, and it will give you the broadcast address. Let me take a couple of examples for it, and that will help clarify the concept. Example 1. We are given an IP address 150.20.30.60. Now, looking at the first octet, first byte, we know it is 150 and it is falling in the range 128 to 191. That's the reason it is a Class B network. And that's why we know that the first 2 bytes represent the network part and the last 2 bytes represent the host part. Now, with the rule that I explained just a minute ago, in a Class B network, if you have to find out the network part, just set the host bits to 0, leave the network bits as it is, and you'll get the network address. Following the same rule, we'll do this 150, leave the network part as it is. I've left it like it, and then for the host port part, just set the host bits to 0. That's what gives you the network address for this particular IP address. And for finding out the broadcast address, same thing, leave the network part as it is, leave it as, and the host bits, set them to all ones. Right? When you all ones, the 8 bits, if we are taking the 8 bits, all ones, all the 8 bits are set to binary 1, that would result in a decimal 255. So that's why this becomes 255, all ones for this byte is equivalent to decimal 255, and similarly all ones for this particular byte, 4th byte, is 255. So that's an example of, first example of Class B network. Example number 2. Here we are given another IP address. In this case, it is the network address. Why it is the network address? How do we identify it as a network address? Because first of all, it's a Class B network because the first octet is 172 and it falls between 128 and 191. That gives an indication that it is a Class B network. Second thing is, since it is a Class B network and the host bits which are the last two octets, the third and the fourth byte, last two octets are set to 0, that indicates that it's a network address. Now the question is, given this network address, what will be the range of IP addresses that can be assigned to host or PCs? And in that, what will be the first IP address, valid IP address, and what will be the last valid IP address that can be assigned to the host? And then we need to find out the broadcast address. So broadcast addresses finding out is pretty simple because we just discussed in the first example. What we do is simply keep the first 2 bytes as it is, and then for the whole bits set it to all ones, right? And that results in 255.255. Now bear in mind, now when we come to the topic of subnetting, we need to be careful that we don't blindly say 255. Need to remember the important point is all the host bits have to be set to ones. And since and only since, because the host bits here are for this particular byte are 8 and 8, we've set them to all ones, and that's why we're getting the number 255. But just don't blindly mug it up. Don't just try to remember in your mind that 255 is the number that represents the host or the broadcast address. Okay, so that's key. Now going back to the question of first IP address, how do you increment? You start from the right? So I will put this byte and I'll represent this into the 8 bits. And then I'll take this one and I'll spread it across like this. So we always increment the numbers from the right. So I'm going to first put this as zeros. And this one I'll increment to 1. So in terms of, I'll just remove the broadcast part from here. In terms of converting this binary 8 bits to decimal, this will result in 0. And this portion, binary portion converted into decimal would result in 1. So the first valid IP address would be 172.16.0.1. Okay. And now if you have to find the last valid IP address, what we do is just simply apply the logic that what is your broadcast address? Broadcast address is the last address, and that is that gave me what? 172.16.255.255. Now if I subtract 1 from it, it will give me the address 172.16.255.254. Okay, so this would be going to 0, and that will give me 254, and this one portion will give me 255. So there, that is how we get our answers. This is example number 2. Example 3, and this is the important example because it further clarifies the concept of how the host numbering increments. So given an address, class B network 188.20.0.0, this is where I've tried to explain the numbering of the host. The first host would be 188.20.0.1, second would be 188.20.0.2, and then these will continue till it goes to 0.254. The next would be 0.255, and the next host would be incrementing this by 1, that would lead it to 0, and then carry over 1. That's where this increments like this, and this will further continue like this: 1.1, 1.2, and this will go all the way to 1.255. Right? I'm just writing the last few octets, and then this will increment to 2.0, and this is how for each of this byte value of this particular third byte, this number will go through the values of 0 to 255. So that's something needs to be very clear, and as quickly as you understand, it will help you understand doing subnetting also in the near future chapters. Okay, that wraps up the Class B network, and next we will go over the Class A.